Welcome. In this video, we're taking a deep dive into the step-by-step foundation construction of a steel warehouse for the Ministry of Energy. This was a large-scale project that required careful planning, precise execution, and some on-the-ground improvisation. Our team was part of the supervision crew, not the main contractor, but we ensured that quality and structural integrity were maintained throughout. Initially, the project was set to be completed in 7 months before the 2024 elections, but due to a few delays and modifications along the way, the project actually took a full year. With a change in government, some processes have become, well, let's just say interesting. But in construction, we always anticipate challenges, and that's exactly what we did. So let's get into it. What is a foundation and why is it important? Before jumping into the actual construction, let's quickly discuss what a foundation is and why it's a critical element of any building. A foundation is the lowest part of a structure, designed to transfer the load from the building safely into the ground. It ensures stability, prevents settlement, and protects the structure from shifting soil conditions. For this warehouse, the foundation had to be exceptionally strong. Given the weight of the steel structure and the large floor area, any miscalculation could lead to differential settlement, cracks, or even structural failure. That's why we had to conduct geotechnical tests before even thinking about excavation. Geotechnical investigations, testing the soil. A good foundation starts with understanding the soil. A team of geotechnical engineers visited the site to conduct tests and pick soil samples for laboratory analysis. These tests included 1. Field density test, sand replacement method, determines the in situ density of the soil, helps us understand whether compaction will be effective. 2. Moisture content determination, ensures that the soil isn't too wet or too dry for proper stability. Excess moisture can weaken the foundation, while dry soil might cause shrinkage. 3. Compaction test measures how well the soil can compact under load. This prevents settlement and ensures uniform load distribution. From these tests, we determined that the allowable bearing capacity of the soil was 250 kilonewtons per square meter, which informed our foundation design. Site clearance and preparation. With the geotechnical test done, we moved to site preparation. 1. Clearing the land-removed obstacles, debris, and vegetation to create a clean working area. Cleared out any harmful substances that could weaken the foundation. 2. Ensuring site accessibility. Constructed temporary access roads for construction vehicles. Set up storage areas for materials like cement, steel bars, and aggregates. 3. Marking the site, setting out. Use total stations and measuring tapes to mark out the exact locations of the foundation elements. Setting out's a critical step. Any mistake here could lead to misalignment in the entire structure. Excavation and temporary storage setup. Once the site was marked, excavation began. The entire area for the warehouse was excavated to a depth of around 2 meters. As excavation was ongoing, materials like cement, aggregates, and steel reinforcements were being delivered. We had to construct a temporary storage shed to protect materials from rain and heat. Foundation marking and reinforcement preparation. Once excavation was complete, we got straight into marking out the footings and preparing the reinforcement. Precision was key at this stage. Any misalignment here could throw off the entire structure. The carpenters got to work, assembling sturdy formwork for the footings. Meanwhile, the steel benders were busy in their workshop, cutting, bending, and tying reinforcement bars to the exact specifications. We followed strict reinforcement standards. High tensile steel, 460 newtons per square millimeter. Mild steel, 250 newtons per square millimeter. Complied with BS 4449. Every piece of reinforcement was double-checked because proper reinforcement is crucial to handling the massive structural loads of the warehouse and preventing cracks in the foundation. Concrete blinding and footing casting. Before placing reinforcement, we first applied blinding, a thin layer of concrete at the bottom of the excavated trenches. Why was blinding necessary? It created a clean, stable base for reinforcement placement. It prevented direct contact between reinforcement bars and soil, avoiding corrosion. With the blinding set, we placed the footing reinforcements and cast the concrete footings. But here's where things got really interesting. To guarantee uniform load distribution, we didn't just cast isolated pad footings, we also connected them with strip footings to counter differential settlement. Throughout the casting process, poker vibrators were in full force. Why did we use poker vibrators? They helped eliminate air pockets, ensuring dense and compact concrete. Without vibration, voids could form, weakening the foundation. We didn't take any chances. Every section was vibrated thoroughly to achieve maximum strength. The entire site buzzed with activity as concrete mixers delivered fresh batches while laborers poured and leveled the mix. Short columns and anchor bolts installation. Once the footings were cured, we moved on to casting short columns within the foundation. These weren't just random columns. They had a critical role in the steel structure assembly. Before full casting, anchor bolts were welded and positioned precisely at each column base. Getting these bolts aligned perfectly was crucial. If they were even slightly off, the entire steel frame could become misaligned. To prevent the anchor bolts from getting clogged with concrete, we covered their threads with plastic bottles. A simple yet effective trick. Since this project was near the sea, we took extra precautions. We applied damp-proofing paint to all foundation elements. Why? To prevent water ingress that could weaken the foundation over time, to protect against salt attack, which can corrode steel reinforcement. Blockwork and on-site modifications. With the short columns in place, we moved on to laying blockwork for foundation partitions. But here's where we had to adapt. Because of the foundation's depth, we introduced a reinforced concrete beam within the blockwork to stiffen the structure. These on-site modifications were essential to ensuring the foundation could withstand lateral forces and remain rock solid. Hardcore filling and compaction. Once the blockwork was complete, the foundation partitions were filled with hardcore. The filling was done in layers, with each layer compacted to ensure there would be no future settlement issues. Proper compaction was key, no shortcuts here, because any loose fill could lead to structural instability down the line. Ground floor slab casting. With the foundation fully prepared, we turned our focus to casting the ground floor slab, a crucial step that would serve as the base for the entire warehouse. Reinforcement mesh placement. Before any concrete was poured, a steel reinforcement mesh was laid across the entire floor. Why? To minimize surface cracking and distribute loads evenly across the slab. To ensure long-term durability, this warehouse was built to last. Concrete pouring in sections. Given the massive floor area, we cast the slab in bays. Shorter direction was done per construction joints, while longer span by expansion joints. With reinforcement in place, it was time for concrete pouring. Concrete shooters delivered fresh concrete straight to the work area. Rollers and rakes spread the mix evenly across the surface. After some time the concrete was poured, we applied Dry Top FH, a non-metallic floor hardener. Why Dry Top FH? It significantly enhanced the durability of the floor. It increased wear resistance, making the floor capable of handling heavy loads and industrial activity without damage. It gave the surface a good finish. Once the floor hardener was applied, power float machines went to work, preparing the surface and ensure a slight degree of roughness to induce friction when vehicle tires move along the surface. Curing and steel column erection. With the concrete slab set, curing was the next priority. We kept the surface moist to prevent premature drying, which could lead to cracks. Curing was carefully monitored to ensure the slab gained maximum strength over time. As the foundation wrapped up, steel columns arrived on site and were being positioned for installation. The real structure was about to take shape. At the same time, office apartments within the warehouse premises were also under construction. The project was coming together piece by piece. Final thoughts and conclusion. And that's the entire journey of how we constructed the foundation for this massive steel warehouse. It was more than just pouring concrete and laying blocks. It required engineering expertise, precise execution, and on-the-ground problem solving. We encountered challenges, adapted, and delivered a solid, long-lasting foundation that would support the warehouse for decades to come. If you found this video insightful, don't forget to like, subscribe, and drop a comment. See you in the next one.